In this memory jogger, we will remind you of the concept of takt time and the takt time calculation. Takt time, or takt, is a German word that refers to the timing or tempo of a musical passage. Other ways to think of this are the beat, or the rate. It is both calculable and measurable. For your mixed model line, takt is the line's formulated production rate. This rate is calculated and is a design parameter for the line. Those of you who studied music must be familiar with the device pictured in this slide. It's a metronome. The mechanical version you see pictured here has an adjustable weight on the pendulum. The lower you set the weight, the faster the metronome beats, and the higher, the slower. Now, imagine each process on the line having its own metronome, hence its own takt time. Part of your job as a line designer will be to calculate takt for all processes on the mixed model line. Let's see what that calculation looks like. The takt time calculation is very simple. The calculation is performed by taking the effective minutes for a process and dividing that value by the volume of product going through that process, which we agreed earlier to call the process volume. Effective minutes are measured in the number of working minutes per day, and the process volume is measured in units per day. The resulting unit of measure for takt is minutes per unit. Takt is measured in time, seconds or minutes or hours per unit of product. So let's take a look at some sample calculations. For our three calculations, we held the effective minutes as a constant at 452.8 minutes per day and introduced three different volumes, one low volume example, one high volume example, and one in the middle. Low volume. Take a look at the calculated takt, 1,811 minutes per unit. Now picture that metronome. The pendulum hits one side every 1,811 minutes. At that time, the line should finish a unit of product on average. Considering that a day lasts 452.8 minutes at this plant, it means that it will take approximately 4 days for every takt. Takt gives you an approximate measure of the amount of work content at a workstation. Can you imagine one person being assigned 4 days of work? How can you expect anyone to commit that much to memory? If you're thinking operator method sheets will come to the rescue, you're giving the tool way too much credit. No OMS will be able to support that much work content and enable someone to do quality work within takt time. Another risk of long takt times is quality. In assembly environments, you tend to cover past work with current work. Should there be a mistake in past work, you'll be hiding those mistakes, converting mistakes into defective products. In the case of long takt times, you have to consider forcing a rotation scheme that makes operators move in and out of workstations through time frames much shorter than takt. Another tool you need to think about is the case of what is known as the call over TQC, which requires an operator to call someone over. That could be another operator, a utility person, a line leader, etc., whenever he or she is about to cover the work. The bright side of the long takt is that long takt time lines tend to be very forgiving when it comes to balancing the work, since there's so much time to catch up within each cycle when natural human variability causes a delay. High volume. Can you picture yourself working at a rate of 0.022 minutes? That is 1.2 seconds per unit. Can you? I'm sure you're laughing and saying, no thank you, right now. And you're right to feel this way. When takt gets into very small numbers, you need to start thinking automation. Very short takt time lines are also very challenging to balance, since there is no time to overcome natural human variability. Finally, the air conditioning unit is somewhere in the middle. It's in the average zone, where takt is neither too long nor too short. In this case, you will face common challenges when it comes to balancing. Many of the default considerations, like 1 IPK, are standard for this type of line. This concludes this memory jogger on the topic of takt time.